this question, we have a stone being pulled up at constant speed, and that constant speed, immediately we should be making the connection, constant speed, acceleration is 0, F net equals 0. Forces are balanced. By a cable attached to an electric motor, so that's how it gets to be constant speed, 12-degree incline, weight is 1.5 times 10 to the 4th newtons. The tension, 4,200 newtons. On the diagram, draw arrows to represent the forces acting on the block. Now on the block, we have gravity acting this way. Should actually be a little more precise with that. We should have gravity from the center of the body acting like this, treated as a point object, and the normal force acting like this, represented by the surface. We have tension in this direction, and in the other direction, we have the force of friction, and we have the force of friction. That's it. So all of those forces should add up to 0 because it's moving at constant velocity. All right. So we drew the forces acting on the block. Now we're careful not to draw the components. The components we can draw somewhere else, like say down here, and we can say this is FG. This is FG perpendicular, FG parallel, and that's theta. So sine of 12 equals FG perpendicular over FG. So FG parallel is FG sine of 12. And by the similar token, FG perpendicular is FG cosine 12. So those are two expressions there, which means if we redrew those forces, we have force of tension like so, force normal like this, we have force of gravity perpendicular, we have force of gravity parallel, and we have force of friction acting in this direction. And so the sum of those three forces must add up to 0. Of course, the vertical ones must also, but we're not really concerned so much about those. We know those are equal. And the sum of the left side is equal to the tension in the right side. All right. So next we're asked to calculate the magnitude, that means just the number, of the force of friction acting on the block. And our dear friend Newton's second law will come into play here. F net equals the sum of the forces, and the net force is ma. And the sum of the forces in this case is Ft plus Fg parallel plus force of friction. And what we are asked to find is the force of friction. We know the acceleration is 0. So the force of friction then is minus Ft minus Fg parallel. And minus Ft we are given as 4,200 newtons, minus 4,200. And the force of gravity parallel is 1,019. $1,081. No, the force of gravity parallel is 3,119. So minus a minus 3,119 gives us a positive 1,081 newtons. So now if we go back to our drawing of what we said should happen, we have force of tension like this, 4,200, positive and negative directions. And then we have force of friction, which is minus 1,081, excuse me. And we have the force of gravity parallel, which is minus 3,119. And if we add these two up, lo and behold, we get exactly 4,200. Now we just want to be careful because we can only express these in two significant digits. So this should be expressed as 4.2 times 10 to the third. This should be minus 1.1 times 10 to the third, and this should be minus 3.1 times 10 to the third. And so we still see they add up to minus 4.2 to be balanced with a positive 4.2. So the friction, the magnitude is 1.1 times 10 to the third newtons.